I want to welcome everybody back who have tuned in and listened to our two previous webinars, and welcome all the first timers. So good morning and good afternoon for everybody out there. This is the third and final installment of our web series on the FCC challenge processes. In this webinar, all the attendees listening in are going to be will be discovering details on the mobile broadband availability challenge process. Real briefly, just a couple housekeeping items previous to the other two that we've done in the past. All attendees are muted automatically, and this session is also being recorded. And at the end of the webinar, we'll spend the last 15 minutes doing a Q&A. Please put all your questions in the Q&A piece on the Zoom call, and then we'll, Sean and I can get to those at the end of his presentation. For all you first timers, my name is Andrew Scampone. I'm a technical manager for Michael Baker International. I am located in Pittsburgh, the Pittsburgh office of Michael Baker. I'm a technical manager at Michael Baker, leading a team of GIS specialists and associates in the broadband group at Michael Baker. We do various broadband work, and we focusing on doing a lot of broadband support on the local and state level as well. Also, I have with me Sean Carlton, who's going to be leading the presentation today. He's a GIS specialist who works in the Baker broadband team and focuses and has been focusing his attention on these challenge processes that the FCC has available. Sean, real quick, do you want to do a little quick intro for yourself?
Thanks, Andrew. Hi, everyone. My name is Sean Carlton. I'm a GIS specialist with Michael Baker. I have 13 years of GIS experience in land acquisition and broadband. My background includes work with federal agencies, local and state governments, and NGOs. This work has included federal land and right-of-way and broadband mapping, creation of web applications, geospatial training, and technical support. Back to you, Andrew.
All right, thanks, Sean. So real briefly, before Sean gets started, just to, I mentioned it already at the beginning, but this is the final webinar of our three-part series on the three types of FCC challenges that are currently out there. The first webinar Sean and I did was the Broadband Serviceable Location Fabric Challenge, and we did that webinar on November 1st. That one focused on the serviceable locations within the FCC fabric, where all individuals can challenge the validity of that serviceable structure. The second webinar was after the new year on January 5th, and it focused on the fixed availability challenge, where users can challenge provider data. Examples could be what kind of tech that was offered, the speeds that are available to buy, and the number of providers available at any given location within that fabric layer. Today, we want to focus, this webinar is going to be focusing on the FCC mobile availability challenge, where users can challenge based on mobile provider coverage. Kind of switching gears a little bit here. The two webinars me and Sean gave are also available on YouTube. I can put the two links. I'll put the two links in the Q&A for those who maybe for the first timers who didn't attend those previous two. And you can also go to YouTube itself and just do a search on Michael Baker Broadband, and you'll find those two videos as well. Real briefly, as you're all aware, the FCC, the reason why me and Sean are doing these is the FCC is making efforts to improve the ways to determine broadband availability throughout the country. It's through that Broadband Availability Act. I think it was signed into law in March of 2020, and it set up the ways to improve the accuracy of the FCC mapping. The data is now becoming more granular and being by using those serviceable location points instead of having the FCC to rely on census block level. Also, the FCC national map what became available on November 18th shows those serviceable location points for both fixed and mobile. Anybody can now challenge those locations and the provider availability of those points. The challenges on the FCC map are called individual challenges. The FCC map that broadband map is www.broadbandmap.fcc.gov. If anybody hasn't checked it out yet, I'm sure most of you have. Sean's going to be focusing his presentation on the mobile side of the challenge process for both individual and bulk challenges. He's going to be showing you the different mobile availability challenge thresholds and on the ground speed test collection techniques that have to be met for the FCC even to consider the challenge valid when you submit the data. Along with these steps of uploading, along those means, Sean's also going to show you steps of how to upload the bulk challenge to that broadband data collection interface on the FCC website. So without further ado, Sean, I'll let you fire up the PowerPoint and you can take it away.
Thanks, Andrew. I'll go ahead and share my screen real quick. Can you see my screen all right?
Yes, I can see it.
Okay, great. Okay, I'm going to go off video while I present. Okay, for those of you that attended our first two webinars about the fabric and the fixed challenges, as Andrew said, welcome back and thanks for joining us again. The mobile challenge process is perhaps the most technical challenge type, and there are a lot of moving parts. So we probably won't touch on everything today, but at the end of the webinar, we'll post a link and a QR code to our Challenge Hub, which is constantly being updated as relevant information comes out regarding all of the challenges, which are fabric, fixed, mobile, and bead. I'll also share our contact information so you can reach out to Andrew and myself directly if you have any questions after the webinar as well. We're all here today to learn as much as we can about the mobile challenge process. As I mentioned earlier, the process has a lot of moving parts, data specs, and documentation, which can be time-consuming and overwhelming to navigate. My hope today is that everyone leaves here with a clearer picture of what is involved in the mobile availability challenge process. The purpose of the mobile challenge process is for the FCC to collect granular data to better determine where mobile broadband is and is not. The challenge process allows the FCC to collect that data to maintain accurate maps. In order to get the most accurate data, the FCC has set up a challenge process where governments, service providers, other entities, and individuals can challenge the availability of mobile broadband. If submitting bulk challenges, an entity must be registered in the BDC system. Individual challenges can be submitted directly in the FCC speed test app, which we'll touch on later as well. Entities may submit bulk challenges using their own hardware and software to collect speed test data. For those entities using their own hardware and software, the process is a bit more complicated than individual challenges, and submissions must be certified by a qualified engineer or official. Here's a high-level overview of the topics I intend to cover today regarding the mobile availability challenge process. First, we'll briefly talk about hexagons and how they play a part in the mobile availability challenge process. And then we'll talk about the 3 thresholds that must be met in order for a challenge to be considered a challenge. As with fixed availability challenges, there's crowdsourced data and challenges. So we'll talk about the differences between the two as it pertains to mobile availability. I'll then discuss the process for governments and third parties. We'll discuss bulk challenge submissions and briefly how providers rebut challenges. Lastly, I'll discuss individual challenges and show a potential approach to mobile challenges. Mobile availability challenges will be binned using hexagons. The hexagons are based on Uber's hierarchical spatial index. Uber created a hierarchical spatial index for binning ride requests and then ultimately made it open source. The same hexagons will be used for the purposes of grouping or binning challenge submissions. Hexagons are great for analysis because their center of each hexagon is the same distance to the center of its neighboring hexagon. We can see in the images on the right that the center of triangles or squares and the center of their neighbor are not always the same distance. The image on the far right, however, depicts the same distance from the center of each hexagon to the center of any neighboring hexagon. Hexagon's resolutions range from 0 to 15, where the smaller the number, the larger the area in which the hexagon encompasses. This means that a resolution 0 hexagon contains the most area, which is depicted in the list of resolution levels on the right. For the purposes of the mobile availability challenge, the FCC will center challenges around resolution 8, which are slightly less than a square kilometer in area. Smaller areas such as resolution 9 hexagons could result in disparate challenges that may require excessive testing by providers. Resolution 10 hexagons and beyond likely exceed the granularity of propagation maps, which were not designed to provide that level of precision. Parent and grandparent hexagons of resolution 8 hexagons will be considered challenged if more than half of its child hexagons are challenged. Each hexagon has 7 children nested within. When at least 4 of those child hexagons are challenged, the parent hexagon will also be considered challenged. So what can be challenged with regards to mobile availability? Challenges will be permitted for 3G, 4G LTE, and 5G NR coverage maps. Voice maps, meaning voice coverage, are excluded from the challenge process and only applies to mobile broadband. Outdoor stationary and in-vehicle tests are permitted. Rural and urban areas can also be challenged for mobile broadband availability. There are 3 different thresholds that must be met in order to be considered a challenge. The first threshold is the geographic threshold, which means that failed tests must be geographically distributed across a hexagonal geographic area. The second type of threshold is the temporal threshold, which stipulates that tests must be taken at different parts of the day. The final threshold is the testing threshold, which dictates that there must be an adequate number of tests conducted in a hexagon to reach a statistical significance. And next, we'll take a deeper dive into each one of these thresholds. The geographic threshold pertains to grouping speed tests by location. The location of each speed test will be associated with a particular hexagon cell based on Uber's H3 hierarchical index that we discussed earlier. The smallest cognizable challenge will be to a resolution 8 hexagon. Resolution 8 was selected by the FCC because it, quote, strikes an appropriate balance as the smallest resolution for cognizable challenge. Ultimately, the logic is that using smaller areas would lead to require many more tests in a smaller hex to achieve a statistical significance. To satisfy the geographic threshold, at least 4 of the 7 child hexagons at the resolution 8 must contain 2 of the same test components. When we mention test components, we mean either upload or download speed being a component. One of those components must be negative in each hexagon, and each hex must be drive testable. When talking about 4 of the 7 child hexagons at resolution 8, we're ultimately talking about children within a resolution 8 hexagon. So the 4 of the 7 children are actually resolution 9 hexagons, which the FCC refers to as point hexes. On the right-hand side, you can see 2 scenarios depicted in the hexagons in each image. The image on the left shows that we have satisfied the stipulation that 4 out of 7 hexagons have a negative component depicted by the red dots. The green dots are positive components. The right image shows that the geographic threshold has not been satisfied since 4 out of 7 of those child hexagons do not have a negative component. To further complicate the process, 4 out of 7 children are not always needed to satisfy the geographic threshold. The image on the lower right shows how many resolution 9 hexagons are needed based on the number of accessible resolution 9 hexagons. For example, if 5 resolution 9 hexagons within a parent are accessible, only 4 of those resolution 9 hexagons are needed to satisfy the threshold. If only 3 child hexagons are accessible, only 3 children are needed to satisfy the geographic threshold. I've mentioned drive testing and accessible hexagons a couple times now, but what exactly does this mean? In order for a point hex to be considered accessible or drive testable, a road must intersect with a resolution 9 hexagon, but it can't be just any road. The road classification used is based on census roads classified as S1100, S1200, and S1400 roads. Those roads are considered primary, secondary, and local roads, respectively, which means that roads such as ATV roads and trails are not considered when determining the accessibility of a point hex. To determine which classification of roads you're working with, you can find it in the attribute table under the MT-FCC field. Coincidentally, this has nothing to do with the FCC that we usually talk about, and it stands for Math Tiger Feature Class Code. Moving on to the second threshold, which is the temporal threshold. In order to satisfy the temporal threshold, each resolution 8 hexagon must contain 2 negative components of the same type, with the time of day difference at least 4 hours different from 2 other negative components of the same type as the first set. Now, I understand that this is a confusing mouthful and hopefully can clear up any confusion regarding what this actually means on subsequent slides. Here we have an example of a successful temporal threshold where 2 negative download tests are conducted at 10 a.m. and noon on the same day. 4 hours later at 4 p.m., another negative test is completed, followed by an additional negative test 2 hours after that. Since the last test of the first set was 4 hours before the first test of the last set, the guidelines of the temporal threshold have been satisfied. Here's an example of an unsuccessful temporal threshold where the same first set was conducted at 10 a.m. and noon. The first test of the second set was conducted at 2 p.m., which is only a time of day difference of 2 hours. So this would be an unsuccessful temporal threshold. While we're on the subject of unsuccessful temporal thresholds, it's important to note that if, for instance, our first set occurs at 10 a.m. and noon on one day, and then we test again at the exact same time the following day, it would still be an unsuccessful temporal threshold because the requirement stipulates the time of day, which stipulates that the time of day difference, which is very different than just stating that tests must be 4 hours apart. So when we say time of day difference in air quotes, that means that if you test in the morning one day, you can't just test again the next morning or the morning a month down the road because they have the same time of day. That being said, tests are valid for 1 year and must be conducted after 6 a.m. and before 10 p.m. The time of day difference is important because it shows poor availability throughout the day instead of just day to day at the same time. The final threshold is the testing threshold, and in order to satisfy this threshold, a statistical significance needs to be present, meaning that a certain number of tests must be conducted in a resolution 8 hexagon to meet the requirement. If fewer than 20 challenges exist in a hexagon, at least 5 negative test components of the same type must be conducted. If more than 20 challenges occur in a hexagon, there's a minimum percentage of negative tests required. In order to meet the minimum required percentage of tests, it is dependent upon the number of tests being conducted. For example, if 21 to 29 tests were conducted, 24% of the tests are required to be negative. The percentage goes down as the number of tests goes up. So for instance, if more than 100 tests were conducted in a hexagon, only 16% of those tests are required to be negative. As mentioned before, a parent and grandparent hexagon will be considered challenged if at least 4 of its child hexagons are challenged. Governments and third parties can submit on-the-ground mobile speed test data to challenge mobile broadband coverage. Challenges can be submitted via the FCC speed test app or another approved third-party app. If an entity is using their own software or hardware, the entity must also submit a description of the methodology and also ensure that the testing collects a defined set of metrics. The process is, lengthy and complicated, so bear with me over the course of the next few slides. For a description of methodology, this includes a narrative overview of the testing solution that was used. This includes, but is not limited to, the description of the procedures and whether the test is app-based, software-based, or hardware-based. Not only is this type of software and hardware, the type of software and hardware used required, but the URL link to that software and hardware product is also required. Additionally, the data must be certified by a qualified engineer or official. Adding on to the requirements is whether the testing software impacts the behavior of the device used for testing. This can include locking the device to a particular radio access technology or spectrum band. Information about the device or devices used in testing is required as well. Does the device have an internal or external antenna? If the device has an external antenna, what is the length of that antenna? What is the data service plan of the device being used? These are all data points that need to be captured if you're using your own hardware and software. The hardware and software will need to capture a lot of information during the actual test as well, such as the duration, the test server type, the geographic location of test servers, estimated number of servers, and the bandwidth that has been provisioned for those test servers. Bulk speed test data can be submitted directly in the BDC system, either through file upload or through Filer API. Maybe asking yourself if there's a data spec for these speed tests if using your own hardware and software. And yes, you are in luck. There is in fact a data spec, which can be found at the blue URL at the bottom of the slide. Keep in mind the data spec is highly technical and any challenge file must be submitted in JSON format. The speed test data will be validated by the FCC to ensure the speed test was taken within the provider's claimed coverage area and ensures that tests were taken between 6 a.m. and 10 p.m. local time. Here are several screenshots from the data spec just so you can see what's involved before you rush off to download it. This is by no means an exhaustive list of everything in the data spec. So if you plan to use your own hardware and software for the purposes of speed tests, make sure you read it thoroughly. For any of you that joined us for our last webinar on fixed availability challenges, we briefly discussed crowdsource versus challenge data. Mobile availability also has crowdsource data and challenge data, and while both have similar aspects in the data spec, both have key differences as well. Crowdsource data are used to inform the FCC's quote-unquote broader understanding of mobile provider coverage, while mobile challenge data is specifically for the purposes of disputing a mobile provider's coverage. With crowdsourced data, submissions only need to include upload or download speed. However, you may submit both. With challenge data, both upload and download data are required. And lastly, the provider is notified, but is not obligated to respond when it comes to crowdsourced data. Conversely, with challenge data, the provider is notified and is required to respond within 60 days. If you're submitting bulk challenges into the BDC system, the workflow is a bit different from fabric and fixed submissions. The first part remains the same, where on the submissions dashboard, you'll select create submission. Under the submission type, you'll select crowdsource and challenge data, and under crowdsource and challenge type, you'll select bulk mobile challenge. Clicking create submission will then take you back to the submission dashboard where you'll select bulk mobile challenge on the submissions dashboard. On the bulk mobile challenge page, you'll see a submission section and the total tests section. The submission section is the number of files you have uploaded that are under review, accepted for filing, or rejected. Once a submission is accepted, the total individual tests will appear on the right-hand side. Pending FCC processing are the challenges that are awaiting FCC adjudication, while rejected or invalid challenges are those challenges that the FCC has deemed invalid and subsequently rejected. If any challenge counts appear in the accepted for challenge process count, these are the tests that have been included by the FCC in the mobile challenge process. Lastly, the included in challenge count denotes the tests that have been included in a challenged hexagon. You'll then click methodologies to add your custom methodology that you use for your speed test. On the methodologies page, you select create methodology, which will bring you to a screen with 3 cards that need to be completed. The first card is to add the details of your methodology by selecting the edit button. A modal will appear that allows you to fill out the details of your custom methodology. Once you have filled in the various aspects of the methodology details, click save. Once you've filled out your methodology details, they will appear at the bottom of the screen. And the second card to be completed is to upload a narrative document describing your methodology. Once you navigate to your file, click Upload Data. You'll now see that the narrative description has been uploaded and is marked as valid data. The last card is to add all the server information for your custom methodology. Once you've completed all the required fields, click Save. Once you've completed all the cards, your server info will appear under the Add Server card. By clicking Methodologies in the bottom, you will return to any and all custom methodologies that you've created in the BDC system. You're now ready to submit your challenge files. On the bulk mobile challenge screen, click Create Submission, and you're greeted with 3 more cards that need to be completed. Clicking Upload will launch a modal where you can select the methodology you created and then browse to your JSON file. Select Upload Data to upload your JSON file. If your JSON file throws any errors, correct those errors in the file and then re-upload. Lastly, you'll be able to provide any additional description if necessary and then certify your data. Once you have filed your submission, providers have 60 days to respond to any challenges that make it through the FCC adjudication process. A provider is required to submit on-the-ground data or potentially network infrastructure information in order to rebut a challenge. If a provider concedes a challenge, the provider will have 30 days to update its mobile availability coverage. The coverage will then be reflected in the national broadband map. For those of you that wish to submit individual challenges via the FCC mobile app, the process is relatively straightforward and does not require the BDC system. Once you download the FCC speed test app from the App Store for your particular device, you'll first need to supply your contact information to the FCC. To submit a challenge speed test, you'll need to tap the appropriate button in the app. On the next screen, you can read a bit about how the challenge works and then tap Get Started to advance. Here, provide your contact information associated with the challenge. On the next screen, you'll need to certify to the test conditions that you have mobile data turned on and airplane mode turned off, and that you're a subscriber of the provider being challenged. Also, you're attesting that your speed test app and your device are working normally. You'll then pick if you are an outdoor pedestrian and stationary or in vehicle and mobile. Tapping Start Test on the next screen will notify you of the data usage from the app compared to your preset data limit, and once again prompted to start the test. The test will do its thing and run through all the metrics needed to complete the test, and after tapping Finish, you can either test again, view your test history, or tap on Settings where you can export those tests to a CSV and JSON file. These tests are automatically submitted to the FCC, so there is no need to export and submit them within the BDC if you do choose to export those tests. Your approach to testing may be different based on your given geography, but one way to approach challenges is to determine how to meet all the required thresholds. Determining the number of tests in each drive testable hexagon is the first step. I came up with a simple formula on the right where X is the number of accessible children. So if there are 3 accessible children, a total of 18 tests are required. And if you're testing the big 3 providers, you'll multiply this number by 3 to give you a total of 54 tests in a particular hex 9 polygon. If a hexagon only has 1 child, 6 tests are needed, which conveniently exceeds the minimum number of 5 required negative tests, if all but one of those tests are indeed negative. If a particular hex 8 polygon has 5 or more accessible hex 9 polygons, this can be treated the same as 4 children hexagons. You can see in my attribute table on the right in the children_final field where anything 5 and up got reclassified to 4. The tests_final field is the tests field which has been multiplied by 3 to account for all 3 of the big providers. And if you're testing big three providers via the FCC app, you'll likely need 3 different devices with a mobile data plan for each provider. And you may be able to get by with 3 different SIM cards in one device as well, but it might be kind of clunky swapping out SIM cards. The amount of testing required to meet all the thresholds can be a lot. So you may need a way of reducing the hexagons that ultimately get tested. We have 4 different scenarios here, with each subsequent scenario adds an additional criteria to reduce the overall testing needed. For the area in question, we had conducted mobile speed tests at various areas throughout the area nearly 2 years ago. Using those tests, I selected only point locations that had a failed component, either upload or download, in our initial mobile tests, and I selected them for all 3 providers. So for scenario 1, the criteria to test a hexagon is that it must be accessible and have a failed component from our previous testing. The criteria gets more selective, with ultimately scenario 4 being the most restrictive, where a hexagon must be drive testable, have a failed component, contains unserved fixed availability, intersects with one of our opportunity areas that we had internally identified, and must not be within an awarded RDOF area. The red text shows how I went from 12,888 tests needed in scenario 1 and reduced that to 3,438 tests in scenario 4 in an effort to target the hexagons being challenged. We identified an internal process for testing the selected hexagons based on the criteria established in the last slide. We determined that it takes about a minute to run a test on the FCC speed test app, and the text in red is the overall hours needed to conduct those tests. Now keep in mind that this does not include drive time. This is time spent purely running the FCC app. I looked at optimizing drive testing for field crew and how that could be accomplished for a given geography, whether it be a county, a city, or some other area. This is important for reducing overall costs associated with testing. Using the traveling salesman problem, we can take a network of roads and nodes and determine the shortest path to all of the hexagons using that road network. This involves ensuring that the topology for that road network is correct, where there are breaks at intersections. Nodes placed within testing hexagons and snapped to the road network are needed to inform the algorithm which hexagons will be visited. The image on your right took 143 hex9 polygons in scenario 4, mentioned previously, and a road network of roughly 19,000 features to determine the shortest path to all hex9 hexagons starting from any hexagon. It may not look like 143 hexagons at this extent, because the hexagons you're able to see are at the resolution 8 hexagon that contain those 143 accessible hex9 hexagons. So what's next? Michael Baker will be conducting more broadband related webinars, and more information will be forthcoming regarding the content of those webinars. Mobile broadband challenges have already begun and will allow users to challenge mobile broadband availability by utilizing on-the-ground speed tests through the FCC speed test app or another approved third-party app. Additionally, entities will be able to submit both challenges that adhere to the FCC's data spec via BDC, API, or other means. We've created a challenge hub that is free and openly available to stay up to date on the latest information regarding all the FCC challenges. That QR code will take you directly to the hub, and we'll also drop a link in the chat. There's a lot of information on the Challenge Hub, from web mapping applications, story maps, and other applications, so feel free to poke around. We're constantly updating it as well as new information is getting released for all the various challenge types. Ensure that you have the necessary staff or vendor to support your challenges. Always follow BDC guidance and work closely with your broadband office. Thank you all for taking the time out of your busy day today to be here, and feel free to contact myself or Andrew.
Thanks, Sean. We only have one. Anybody else want to chime in the Q&A? Feel free. I have a couple questions here in the chat. So let me get into them here. Let me share my video on too. So I guess, Sean, the first question is about defining mobile broadband. What's the speed and capacity level? So maybe talk about what negative and positive means in terms of what fails.
Yeah. So if you're testing and challenging against 4G LTE, a failed component would be if the download speed is under 5 megabits or download and 1 megabit upload. If it is 5G, then it's 7 download and I believe 1 upload. And then if it's 5G NR, it is 35 and 3, but I would have to double check on that. The negative components are determined directly by the technology that you're challenging. So if it's 4G LTE, a failed component is specific to 4G LTE or 3G, and then the same goes for 5G as well and 5G NR. And
the mobile app that you have will let you know whether you fail or not anyway, right? Correct?
Yep. The app will record all those metrics and it'll tell you if you're connected to a 4G connection or a 5G connection.
Okay. What is provisioned bandwidth for testing servers?
That's a tough one. So the provision bandwidth is the amount of incoming and outgoing data for a particular server. So if a particular server is provisioned to accept 10 gigabits of data incoming and 10 gigabits of data outgoing, then that's how much data has been provisioned, or how much bandwidth has been provisioned for a particular test server.
Okay. And then does FCC provide a map of the hierarchy hexagons with base map features to facilitate test planning?
The FCC does not provide a map of hexagons in the way that I believe what I think you're asking. They show these hexagons on the national broadband map, but only at certain extents. But you can download the hexagon 6, 7, 8, and 9 hexagons for any state from the FCC. They have a public facing box account that you can download shape files or geo packages for any state or territory, and at those 4 different resolutions.
And then can you touch on about how the rebut process by providers, I guess that timeline?
Yeah, so providers have 60 days to respond. If they don't, let me back up. So if any of your challenges make it through the FCC adjudication process, and it turns out that it's a cognizable challenge, the provider has 60 days to respond. If they don't, then the challenge is upheld and they have to update their coverage availability within 30 days so that gets reflected in the national broadband map. I would assume that the process is the same as fixed, that if they don't concede that challenge, that provider and challenger have 60 days to work out those differences. And if they don't, then the FCC will step in and adjudicate it.
When the FCC steps in to adjudicate, it's basically them just making a decision on their own, more or less, based on what the user uploaded to the FCC.
Based on what the challenger uploaded and the testing methodology, and then any sort of evidence, whatever evidence the provider comes back with, because once those challenges make it through the provider then has the opportunity to supply evidence that they do in fact serve mobile broadband in those areas, and this is done through their own on-the-ground speed tests. And this is why they have to be accessible, is because providers have to be able to speed test as well using through the drive testing methodology. And so if they can't do it with on-the-ground speed tests, then they have the ability to supply their infrastructure information, and what that infrastructure information is will vary from provider to provider, I would assume as well.
Does the testing device need to turn off any other services using bandwidth? Other services than the speed test app. Well, I know you have to shut down your MiFi, right? You have to shut down your MiFi.
Yep, if you are connected to any sort of Wi-Fi connect,
right.
yeah, if you're connected to any sort of Wi-Fi connection, you'll be prompted to turn that off before you can commence any sort of speed test challenge. Other than that, I'm not aware that like you don't have to close out of any like open apps or anything like that. You just have to make sure airplane mode is off and that you're not connected to a Wi-Fi connection.
Right.
And that also that you are in fact outdoors and stationary or in a vehicle and mobile.
Right, and then the fact that you have to have 3 phones with one of the big 3 for each phone.
Correct.
Or like you mentioned before.
Correct. If you want to
have the SIM card, maybe switching SIM cards out, but so that's something also to consider when you're doing the mobile speed test.
Exactly correct. And if you don't intend to challenge the big 3 providers, then you just need one device, but they all have to have a data plan associated with the provider that you intend to challenge.
Okay, a couple more. This is in the Q&A. The road data that must intersect the hexagon that is used for the mobile challenge. Is the road data from federal census data, or what agency center lines are used?
The data specification specifically calls out census data with regards to the broadband data collection, mobile verification process that the census roads of the S1100, 1200, and 1400 road types are used. I mean, you could use your own road data, but you kind of gamble at that point in time if your road data does differ from census data, and you're saying it's accessible based on your data, but it's not accessible based on census data. I would imagine that the FCC is always going to defer to the authoritative data source on this aspect, which is the census center lines.
Okay. All right. Last question is about the slides. So this webinar will be on YouTube in a couple days. So anybody can go check out the Michael Baker Broadband page on YouTube. Like I mentioned earlier, just go to the search and you go to youtube.com, go to the search and just type in Michael Baker Broadband. And you'll see our previous 2 webinars, and you'll see this one up in a couple days. So maybe just wait, maybe Monday, it should be stood up. But that's all the questions that we have. I appreciate everybody and thank you for the questions and thank you for participating today. Let me double check. Yeah, no more questions. Go check out the other 2 webinars and go definitely check out this one. I know this one was a lot of information. I think more so than the previous 2, because there's a lot more data specs that are involved on the mobile side of things, unfortunately. But anything else from you, Sean?
I don't think so. Thanks everybody for tuning in again. We appreciate all your time and effort with these challenges. It's a lot.
Okay, well, that concludes our mobile broadband challenge webinar, and I appreciate everybody taking time to listen in, and thank you and enjoy the rest of your day.
Thanks everyone.
Take care.
Bye.